Hello, it's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, function transformations as observed by the equations. This time we're going to talk about linear equations. And as you can see, I have a very blank plate right here. We're going to look at what the parent graph looks at first. So I'm going to blow this up just a little bit so that we can look at what the parent graph looks like. And the parent graph looks like this. Now, real carefully, this is y equals x, okay? Our y-intercept, or where we cross the y-axis, is 0, 0. And these are some, and we want to look at the slope of this line. The slope of this line is 1 over 1, okay? It means we go up 1, right 1, up 1, right 1 as we move across the graph. This is very important information because we're going to look at that in terms of what the equation tells us. All right, so we go over here. We're going to look at our slope-intercept form of the equation. Now, the intercept, or the y-intercept, is found with the number that does not have a variable on it. And that's this number here. Doesn't have a variable. All right. What we do know is that in the parent graph, b is always equal to 0. That means our parent graph, if we look at that equation again, b is actually 0. We just don't write it in because if I add 0, I don't change the value of anything. Where the graph, again, this is where the graph intersects the x-axis. Now, if b is plus whatever number it is, our graph moves up the x, or moves up the y-axis. If the number is negative, then the graph goes down the y-axis. So that means our parent graph would be moving up, still have slope, 1 over 1, 1 over 1, 1 over 1. It just lets us know where we are intersecting the y-axis. Let's talk about what the number slope that everybody talks about. Let's talk about what slope tells me. And this is slope here, and I'm actually talking about the absolute value of that number. I'm not going to look at the sign that's assigned to it, whether it's positive or negative. I just want that value of whatever that number is. If that number is bigger than 1, if that number is bigger than 1, then what I have is a line that is going to stretch vertically. Okay, it's going to be more steep. If I was walking across the yard, I'd be hiking up a mountain is what I would have. And then, okay, I have a stretched vertical graph. If the number is between 0 and 1, this means like 0.5, 1/2, 1/3, 2/3, but I'm not talking about a number like 4/3. 4/3 is bigger than 1. I'm talking about a number that is between 0 and 1. I'm going to have a much more horizontal picture. Okay, it's going to be flatter, easier to walk. I'd be walking up a hill instead of a mountain. And this means I have a horizontal stretch. Next, we're going to talk about the sign that is in front of our axis. And we're going to look at the sign values. Okay, the values of those numbers. If it's positive, we're going to go from the lower left to the upper right, just like the parent graph. But if the sign is negative, we go downhill. And this is also a reflection, okay, over the x-axis. Let's look at a picture right here that I have. Okay, here's our parent graph. And if I take the parent graph and I flip it up and down, that means over the x-axis, I get this graph here. As you can see, it's going in the opposite direction. It goes downhill and would be much easier to walk. With that said, this is everything that we can tell from a linear graph, all in one big picture, and I will talk with you later. Have a good day. Bye.